So here we have a O of n squared approach wherein we check for each combination basically ng start and end ng ating subarray and compare lang natin kung alin yung may pinakamalaking total. So we first start at I equals 0, then j equals I. So isa-isa lang natin, getting yung sum from I to j. And then si j mag-increment from j equals I hanggang j equals yung length. So essentially, yung first iteration ng loop natin, I is equal to 0. So it will start here at 0 and kukunin niya yung sum na to. Yung first 2, and then yung first 3, and then, so basically, i-add niya yung next element, and then i-add niya yung next element, and then i-add niya yung next element, and so on and so forth, hanggang makarating siya sa dulo. And every time na mag-add siya, compare niya yung sum dun sa current na maximum sum. So initially, some large negative number. And then, kung maximum siya, siya na yung bagong maximum. And ayun, update lang yung j natin at each iteration. So with debug set equals set to true, when we run this, pwede natin check yan. So yung ating output ayun, starts from 0 to 0. Yung maximum niya is 13. And then it gets the sum from 0 to 1, gets 10. And 0 to 2, negative 15, hanggang makarating siya sa, and 0 to 15, we get negative 3. So next part is, we get the sum from 1 to 1 naman. So ito is that, nag-start is 0, ngayon start naman to 1. So eventually, makakahanap siya ng bagong maximum, which is from 3 to 3. And then from 3 to 10 din. So plus 21. And then eventually, mahanap niya yung maximum of the maximum, which is yung 43 natin. When we go from 7 to 10. So eventually, may mahanap niya rin naman. So complexity analysis, we expect this to be O of n squared. Since for the first time na mag-iterate yung loop, we iterate yung inner for loop ng n times. And then after the first iteration, n minus 1 times, and then n minus 2 times, and so on and so forth. So yung total sum natin is an arithmetic series, n plus n minus 1 plus n minus 2, and so on and so forth, which is n times n plus 1 all over 2. So this means a overall complexity of n squared, assuming na yung other operations natin sa loop natin are all constant, which is a valid assumption since lahat ng naman to is assignment and comparisons. So if hindi natin consider yung complete length, actually yung complete is constant. So ayun, meron tayong n squared na tayong complexity, kaya nga tinawag na n squared approach. And we don't actually use any other temporary variables, so our size is constant at, or our size complexity or series space complexity is 1. So let's think of a divide and conquer approach to this problem. So divide and conquer approach, pwede naman tayo mag-start dun sa pinaka-template niya, which is get the middle and make 2 partitions. And then do something with the middle. So you operate at the left subarray and then you operate at the right subarray. So we can think na since we're looking for the maximum subarray, these two recursive calls, hahanapin nila yung maximum subarray from the low to mid and yung mid to high. So pwede natin isipin na that will return our maximum subarray for the lower partition. And then it gets the maximum subarray dun sa upper partition over here. So yung maximum ng left partition and yung maximum ng right partition, we can consider this as yung ating parang contenders for the maximum subarray of the whole thing. And then, ang kulang na lang nun, so what if kailangan kasama yung middle na element? So, If for example, okay, alam natin yung maximum dito sa left, alam natin yung maximum sa right, ano yung maximum pag nag-combine tayo sa gitna? So, ayun. So, kailangan lang natin isama yung pangatlo na yun. So, ito, sub-array na kasama yung middle element. And hopefully, if wala ka dito sa left sub-array, kung wala yung maximum dito sa left, wala yung maximum dito sa right, it should be here at the middle. Kasi, if hindi kasama yung middle element dun sa maximum sub-array, for sure, nandito siya sa higher or lower na sub-array. So, how does that look like in code? So, ito, meron ng extra steps dito for debugging. Pero essentially, medyo pareho lang yung ating function. So, first, it gets the midpoint, and then it calls yung maximum sub-array for the lower, or for the lower sub-array, and then it calls the same function, or it calls itself recursively, for the right sub-array. So, from low to mid, at saka mid to high. And then we have another function here. Hindi pa natin na-define, but you can already expect kung ano yung kailangan nyo gawin, which is find yung crossing or yung maximum crossing sub-array na tinatawag natin, which is crosses yung middle element. So note lang here, na ginawa natin yung return is a combination or a tuple of the sub-array, I mean yung total, ayun, so 0 yung total, C yung first element yung maximum, no, ay yung start ng maximum, and C2 yung end. So basically, yung kailangan lang natin convert yung 0 na term na C1, C2. C2 siya. So yung 0, if compare natin, siya yung maximize natin. So itong dalawang statements ito is just basically finding yung maximum. So yung C-max natin is C1 if C10 is greater than C20. So otherwise, C20. Then, compare natin siya kay C3. If C3 siya, if mas malaki C30 kay C-max, C-max. Then, ayun, ang base case lang natin is when we have a single element wherein yung maximum sum array natin, yung total sum is just the single element itself, yung value na yun. And then yung start and end ng ating sum array is just the index ng sum element, which is yung either in low and high. And if we have an empty list, we just return a large negative value para hindi siya ma-consider as a valid na container. So what's left for us to do is to define yung ating maximum crossing na sub-array. And of course, it's easier said than done. So we can check, we can always check yung every possible na sub-array, like yung ating quadratic na method. So chinek lang natin lahat ng possible na combinations. But ang difference natin here is we can actually reduce the number of checks we need to do because of our restriction na kailangan kasama yung midpoint. So, going back dito sa figure, dahil kasama yung midpoint, parang meron na tayong endpoint na alam. Kasi basically dito, hindi natin alam kung saan magsisimula or saan mag-end yung sub-array na hinahanap natin. But in this case, we can start from the middle and we can extend right to the right or extend to the left. So since alam naman natin na continuous siya, the middle element will always be there. So mag-extend ka lang to the left and mag-extend ka lang to the right. And if hanapin mo lang yung maximum doon, and yun na yung maximum talaga. So hindi mo na siya kailangan i-move pa. So before kasi, mag-start tayo at one end and mag-iterate over the other elements, and then mag-iiba yung end natin na kinakonsider. So in this case, since fixed yung middle, pwede tayong mag-spread basically to the left and then mag-spread to the right. And tapos na tayo. Hindi na natin kailangan i-modify pa yung middle element. So basically, kailangan lang natin gawin ito. So yung inner for loop, we already know yung I natin. So, isang loop na lang yung kailangan natin gawin. Or actually, dalawa kasi to the left and to the right. So, To put it more formally, here is our implementation. So we basically have two loops. And yung first loop natin gets the maximum subarray na nag-end sa gitna. So uh, starting from the middle element, mag-move siya to the left. So si I natin starts at mid minus 1. And then for each element is mag-I minus 1 lang siya. So starting from the middle, mag-move siya to the left. And then same with the right one, starting from the middle, mag-increment si I, and it moves to the right. So yung maximum subarray to the left, and then yung maximum sum sa right, pag kinombine natin, yung maximum sum crossing. And then it starts from yung left to right. No? Makukuha natin here. And then we can just finish with our helper function. So since recursive siya, and we need to specify yung start or yung starting low and yung starting high, which is 0 and yung maximum line. And then we can eventually nahanap din natin yung ating maximum subarray. So nakalimutan ko lang i-run yung mga cells. So with the debug option enabled, makikita niyo yung intermediate steps ng ating algorithm. So the algorithm starts from 0 to 16 minus 1. And magpa-partition lang siya. From 0 to 16, may 0 to 8, 0 to 4, 0 to 2. And eventually, single element na lang siya, which is yung 13. So siguro makakatulong if we put yung ating array over here. So from 0 to 1, hindi kasama yung 1, we get 13, yung maximum na subarray. So yung left sum, yung right sum is -3. So i-compare lang natin. So yung maximum natin sa left ay 13, maximum sa right ay 3. So pag nag-cross tayo, we get 10. So let me just highlight it over here. So yung first time na magkakaroon tayo ng actual operation is on this subarray. So kinuha natin yung left. So yung left contender natin, isang element lang is 13. And then yung right contender natin is single element and then -3. So -3 and yung 13. And then we get the maximum crossing na sum. So kailangan kasama yung midpoint or kasama yung dalawang middle elements. So that is kailangan kasama si 13 and si -3. So yung maximum sa left is 13, maximum sa right is -3. So yung maximum contender natin at the crossing is 10. So comparing the three contenders, we have 13, -3, and 10. So we select yung ating 13. So essentially, for this subarray, we know that yung maximum is 13. And then eventually, makukuha rin natin for this subarray, yung makukuha natin na maximum is 20. And then for these two na subarrays, ang magiging maximum natin is just 20. So, kasi pag nag-cross tayo, yung maximum natin dito is -5 to the right, and then +10 to the left. Yeah, so from 2 to 3, we get 20. And then, so yung crossing sum from 0 to 2 to 4 minus 1, we get just 5. So negative 5 to the right, positive 10 to the left. And we get yung maximum for all four elements, or for the first four indices, yung maximum is 20. So, and then, and so on and so forth. So hopefully you get a gist of what these statements mean. But eventually, makukuha natin yung maximum subarray starts from 7 and ends at 10. And we get a total maximum of 43. So I hope that made sense. So what's next for us to do is to analyze yung ating implementation. So to analyze the algorithm, nire-write ko lang yung function without yung debug statements para umikli siya. So as you can see here, hindi naman siya actually ganun kahaba. So we just calculate the middle point, call recursive call to the left subarray, recursive call to the right subarray, and our crossing function. And then, ayun, a couple of comparisons, and then just return yung maximum na contender. And then yung base case natin here at the end is just for single elements or no elements at all. So, ayun, it's much more easier to generate our recurrentialization. So, yun nga, meron tayong dalawang recursive calls to half of the list since middle point is half. And then we have the time complexity or yung running time no crossing na maximum subarray. So, and if yung ating cross, tingnan natin siya, dalawa siyang magkasunod na while loop. And yung while loop natin iterates from I equals middle hanggang 0, and then I equals middle to the end. So eventually, ang total number of iterations natin is from start to end, which is just equivalent to O of n. So assuming na lahat ng contents ng ating loops ay constant, so constant ng lahat to, addition, tsaka access sa array, and then assignment, subtraction. So lahat naman sila is constant. So kailangan lang natin makuha yung number of iterations. So yung number of iterations dito, starting from middle hanggang start, and then from middle hanggang end. So end to start yung number of iterations, which is just O of n. So actually, makuha natin yung recurrent solution natin here is quite similar kay merge sort. So 2 times n over 2, 2 times p of n over 2 plus yung merge na linear and a constant na. So I can see na actually yung ating merge sort ay ating divide and conquer approach dito sa maximum subarray also results in a n or n log n or log linear na running time. And then for the auxiliary space complexity, wala naman additional na lists na ginagamit. So we just consider yung depth ng ating recursion, which is just log of n. So similarly, the verdict is, pag kinompare natin, yung iterative na approach natin of n squared, divide and conquer natin is n log n. And then yung memory or space complexity natin, constant siya for the iterative method and logarithmic siya for the divide and conquer approach. So yun, so parang further strengthening our point na yung divide and conquer, usually in applications like this, it can speed up yung ating algorithm, but we take up additional not space. So yeah. Then we have a next video on what we call the master theorem, which should hopefully speed up things pagdating sa pag-determine ng space and time complexity ng ating divide and conquer algorithm. So, see you in the next video.